Today's problem is find bottom left tree value. So let's move to the problem statement. So given the root of a binary tree, we need to return the leftmost value in the last row of the tree. Let's say this is the tree, but so we have left and right. So this is the left and it is the last row of the tree. So we return 1. But what if there is left for this node? So let's take this example. We can see that 1, 2, 3, and 4. We can say that this is the leftmost node, but what the statement is, it has to return the leftmost node of the last row. So can we say that 7 will be the answer in this case? Let's understand how to solve this. So let's see, we have a result, that is result equals to 0 initially, or you can say it's root node initially, that is 1. So first of all, append this one or root node into the queue. Let's say this is the given queue. So we'll just append the first or root node into the queue and check if there is any left or right. So there are left and right. So just pop it up and append 2 and 3 into the queue. Let's say while size of the queue, we are just appending the left and right. So can we say this is the left side and this is the right side of the root? So if I equals to 0 while iterating through the size of the queue, it will be the result. So let's say this is the result, new result now. So just update the result by 2 and check for if it is it has any left and right. So let's say 2 has a left. So just pop it out and append 4. Now we see that 3 is the next element and it has a right left node and a right node. So can we say we have to append this both? So just append 5 comma 6 into the queue and just pop it out, and now the new size of the queue will be equals to 3. So it will be the first element to be popped out and it will be the new result. So let's say 4 is the new result or leftmost child, and let's check for if it has any left or right. So it doesn't have any, so just pop it out and move to the next node. We see that 5. So 5 has a left and no right. So just append the 7 into the queue. And now just pop it out there. Next we move to the 6. So it has no left and no right. So just pop it out. Now new size of the queue will be equals to 7, or it has 7 and the size is equals to 1. So let's say it is moving from 0 to size. So I will be 0 for 7. So it will be the new result. Or can we say that it is the new leftmost child of the tree? So there are no further left or right for this 7. So we just end it up in this. So just pop it out and return the result. What will be the time complexity for this and what is the approach we are using? It's BFS, and we are iterating through every node. So let's say for a node or root 1, it takes order of 1, and there are some n number of, here there are 7 nodes. So let's say it is order of 7 for this, and for this approach the time complexity is equal to order of n, and the space complexity of the queue will also be order of n. Let's move to the code part. So let's first initialize q as q equals to deque, and then what will take, let's say we have to first append a root into the queue. So let's append it, and now while this queue is not empty, we'll just first take n equals to length of queue, and now for I in range of n, let's say we are iterating through the size of the queue, and first let's take a node equals to q.popleft of, it will take the bottommost node of the queue, and then let's say if I equals to 0, this will be the leftmost node. So first initialize a result equals to 0. Let's say result dot equals to this node dot value, and now let's check if there are any left or right. So if there is a left, let's say node.left, then q dot append it into the node.left. And what if there is a right? So let's say node.right exists, then just append this into the q dot right. And now after every iteration is done and all the n number of nodes are into the queue, so just return result dot, or okay, just return result. So just run the code. The code runs fine. Let's submit it and see if it's possible for every test case. Okay, so the code runs fine and it's run for every test case. Let's think of the time complexities now. We are taking n as a length. What if the length is equals to number of nodes? So the time complexity will become order of n, and space complexity is also order of n. And what if a particular node's time complexity, let's say we are calculating only n equals to 1 and there is no further any loop, or let's say there are no any left or right, then the space complexity will be equals to order of 1 and the time complexity will become order of 1. So that is it for today, guys. Hope you have liked the video. If you like the video, please like and subscribe my channel. Thank you for watching.